Hello and welcome to a special episode of Cascadian Mountain Weather. This is Kyle McCrone here with Wyatt Mullen. Today we're going to talk about El Nino impacts in the Washington Cascades. To start out, what is ENSO? ENSO is the El Nino Southern Oscillation. This is a weather phenomenon that repeats itself every 3 to 7 years, varying between colder and warmer periods. Specifically, the phenomenon is looking at the sea surface temperature in the tropical Eastern Pacific. So that's kind of close to like Panama and Peru. We're talking about the waters over there. The trade winds generally in the Pacific move from east to west. So what that does is it moves surface water from the east to the west, thus pulls cold water up from the depths towards those coastal eastern waters near Lake Peru and Panama. And so the strength of the trade winds affects how much water is pulled up. There are certain periods where the trade winds are stronger, and that creates more upwelling, and thus the water is colder in the Eastern Pacific, and that is La Nina. There are other times when the trade winds are very weak, and thus there's less upwelling, and the Eastern Pacific becomes warmer, and that is El Nino. So here is a typical pattern of that El Nino creates. Now, this is by no means a guarantee. It's just that this sort of weather pattern is very commonly associated with El Nino. So what often happens is the Pacific jet stream kind of splits into a polar jet stream and a lower jet stream that is able to sag southwards because of the warmer waters in the Eastern tropical Pacific. As a result, the southern US tends to be a little bit wetter, and the northern US is often drier and warmer. In La Nina, it's flipped. So there's a blocking high pressure over the northern Pacific instead of a low pressure like El Nino. This causes the polar jet stream to be a lot more variable. Oftentimes, it'll kind of move up into Alaska or the Gulf of Alaska and catch a lot of cold, moisture-laden water and then come diving down out of the northwest and hit the Pacific Northwest with these wet, cold storms. It's great for low elevation snow and great for mountain snow. So that just tends to be a setup of La Nina, but it's by no means a guarantee. That just happens to be the signature pattern of La Nina. So next, Wyatt's going to talk about where we are in the ENSO pattern. Are we at La Nina, El Nino? What's going on?
Yeah, so we can look at this kind of oscillating pattern that Kyle's just been describing over the last 40 or so years. You can see that really we measured in like a very specific area, sea surface temperatures. You can see the warmer periods. Those red marks are kind of those stronger El Nino periods. Then you look down to the bluer marks, the lower marks, which are those cooler periods, which are those stronger La Nina periods. So this is looking at the sea surface temperature and specifically the departure from average over the last couple months. And so what you can see is that we have this really warm area in the Eastern Pacific, as Kyle was mentioning, the Pacific area. And you can see that it's kind of 2 to even like to the east, it's warmer. To the west, it's a little bit cooler. So we look at the latest weekly SST stands for sea surface temperature departures, and we see that the big indice that basically describes how strong your El Nino is this Niño 3.4, which includes a little bit of this Niño or most of this Niño 3 region and some of this Niño 4 region. This is where they measure the sea surface temperatures to describe how strong that Niño is. And right now, this is 1.6 degrees Celsius above the long-term average, which means that we are actually officially kind of in like a strong El Nino period. It's a little bit confusing because one of the ways that they measure El Nino is they look at it over a period of 3 months. So it's not like an instantaneous value. They average it over 3 months. But it does look like we are headed eventually into that, that stronger pattern. So we can look at kind of how these classifications, and there's a number of different ways that you can classify, whether it's weak, moderate, strong, very strong. I would say that most groups tend to kind of focus on like the impacts of strong Niños, which is generally above this 1.5 degrees above average. And then you have kind of the weak Niños, which are below that, kind of that 0.5 to 1.5. Of course, you also have the neutral, which pattern, which we haven't mentioned yet. That does occur some years as well. And then you can go down into the weak and strong La Nina patterns, which are when you get kind of below that 1.5 degrees below average. This is just looking at for like going towards the future. It does look like almost certainly we are going to be in the El Nino pattern this winter. They're giving a basically 100% chance through kind of, this stands for those kind of 3 month time periods. So this is January, February, March, February, March, April. El Ninos sometimes only last a year. And so it looks like we could trend back downwards. Here are some of the long-term forecasts. So once again, this is measuring the temperature. We just crossed over the 1.5 degrees Celsius range. It looks like we might get up towards 2 degrees, which would put it on close to some of the strongest El Ninos we've seen. But then it looks like we are going to kind of trend back towards neutral for the summer. This is just another forecast hinting that we might trend up towards that 2 degrees. This is, like I said, there are a number of different ways to measure El Nino. Later on, I'm going to be kind of categorizing into like weak and strong. And like one of those ways is like you can look at like the peak value that it hits. So maybe if you see it up kind of to 2.6 degrees, that's a really strong El Nino. You can also kind of sum your values over the months of the winter that include kind of winter months, and that can help also measure El Nino. So just looking at this shows another way that you can sum up those values and kind of set a cutoff for your weak and strong El Ninos. But really, like what most people are interested in is what the impacts are going to be in the Cascades. So I actually collected data from about the last 50 years from a number of different ski areas or mountains in the Washington Cascades. So we picked Baker, Stevens, Snoqualmie, Paradise, which is near Mount Rainier. Kind of that selection was made based on elevation and also just data. The passes have quite good continuous data. Baker provides some good data as well as Paradise. And so what we're going to do now is we're going to look at kind of some of that snowfall as it relates to El Nino and La Nina. So this is looking back towards the season of 1970-71. And what we can really notice is that like, this is for Paradise, so near Mount Rainier, just over 5,000 feet, 5,400 feet. You can see that the La Nina years tend to be snowier, and the El Nino years definitely tend to be less snowy. It doesn't mean that if you have an El Nino year, you can't get up to that kind of average snowfall, which is pretty high at Paradise. I mean, 700 inches is a lot of snow. And what you can see is even in the worst years, like you're still going to get quite a bit of snow, but you might also get a lot of melting. So we have Paradise here. We can see Mount Baker as well. We can look at Stevens Pass. So Stevens Pass definitely drops down a bit. It's lower elevation at 4,000 feet, doesn't get quite as much snow as Baker. So it only averages about 400 inches a year. But once again, we see this similar pattern where you get some really snowy La Nina years, especially those strong La Nina years. There's a super strong signal for snow on those. And then these El Nino years, it's the strong El Nino years tend to be kind of near average, which is good for us, as I said, because we're going into the strong El Nino. And then we can look at Snoqualmie Pass as well, which is the lowest of these. It's about 3,000 feet and seems to be the most impacted by these snowfalls. So we'll go to here, and here's some of the kind of average data that we might see if you break it down into just El Nino, neutral, and La Nina years. So we can look at Paradise, close to 800 inches in a Nina year, Baker 750, and then we look kind of drop down to neutral, we lose maybe 150 inches. And then we lose maybe another kind of 10% for those Niño years. So overall, for Niños, we get maybe close to 80% of average or normal. And then it's what you kind of notice also is that as our elevation drops, you see kind of that decrease. So Paradise gets about 85% of normal during a Niño, all the way down to about 78% for Snoqualmie. And then if we look at snow depth as well, so this is kind of the peak snow depth, usually is about April, around April 1st, sometimes a little bit later, sometimes a little bit earlier. You can see that we do actually see quite a difference where our Niñas are quite deep, and our Niños will drop significantly. So Snoqualmie might only be at 50 or 60 inches of depth. This is breaking it down to kind of that strong, weak, neutral. Gosh, those strong Niñas are amazing. Paradise gets close to 900 inches of year, compared to kind of average, it's about 700 inches. Baker gets close to 850. Snoqualmie even gets over 500 in a strong Niña versus about 400 or 300, just under 400 in an average year. You can see that strong Niños, though, as we're approaching, are about 80% of normal. But what you might notice, and we might be able to see that better well, I guess we'll look at this first, just showing, once again, we have our strong Niñas in like the dark blue, and then our strong Niños. And what you might see is that the Niños are actually, or the strongest Niños tend to be better than the weak Niños. Our worst years have almost all been the weak Niños, where we might see sometimes 50% of normal snowfall. And what I also wanted to highlight is that during a strong, like the impacts worsen as the elevation decreases. So this is looking at, so we see Paradise kind of on the left here. We see Snoqualmie on the right, and you'll see that we're close to 90% of average snowfall during strong Niños at the higher elevation, and the further north you go. Once you drop down to elevation, kind of where Snoqualmie is, you might only get 70 to 80% of normal. The inverse is true with the strong Niño. Now what we're going to look at is kind of how this impacts both temperature and precipitation. So the big difference between, the big real impact that Niños have is not so much the precipitation is lower, it is that the temperature is significantly warmer. So you can see that, as Kyle mentioned earlier, if you look across the northern tier of the country, you can see warmer than average temperatures. And if you look, precipitation, yes, can be lower across all Niños, but also, like, in the grand scheme of things, this is kind of showing the Cascades, like a couple inches below normal also might not make that much of an impact, because the Cascades get 100+ inches of rain, and this is looking at precipitation, so rain a year. So like 5 inches below normal is not that impactful. This is looking at strong El Niños, which is once again what we're entering. You can see a super, super strong kind of impact in the northern tier of the country for temperatures, right? So we tend to be in Washington 1 to 2 degrees above normal. You might be even more above normal as you go further east. And this is looking at all the Niños since 1970. Sorry, all the strong Niños since 1970. But once again, especially for strong Niños, you don't really see that precipitation impact. One thing that's interesting about Niños is that as the season progresses, or as the winter progresses, they tend to have more or worse impacts in Washington and the Cascades. So November temperature tends to be pretty close to average in Washington. December's pretty close to average. They might even be a little bit colder than normal. Once we get into January, we start to see this pattern develop where we have the warmer than normal temperatures in January, in February, March, and April, where that is really where, like, you can actually get some pretty good snowfalls even in the lowlands in kind of that November, December timeframe. But once you get later in the year, you do see those warm temperatures and kind of a decrease of snowpack. So just wanted to highlight quickly a couple of recent El Niños, kind of in the last 20 years. So we'll go back in time. So 2018-19 was the last time we were in a Niño, and it was a weak Niño. What you can see is that we have this emphasis of much above average normal snowpack down in the California area. And then once you get up into the northern Cascades in Washington, only about 70% of normal. And this is April 1st again. We can look at 2015-16, which was a strong El Nino, our last strong El Nino. Honestly, pretty close to normal snowpack in the Cascades. And we can see that, yeah, like the temperature definitely above normal. This is for this last 2015-2016 strong Nino. But precipitation was above normal to significantly above normal, which is probably one of those reasons that kind of those balanced out. What we then can look at is kind of one of the worst snowpack years in recent history, in modern memory. So this is 2014-15. This was a weak Nino. And gosh, it was bad. I mean, on April 1st, the Olympics had 1% of normal snowpack. North Cascades had 44%. It was bad along the whole West Coast. This was a Nino that kind of like, even like California didn't do well. And what we can see if we look is that the temperatures were significantly above average, 4 to 5 degrees across the region, while the precipitation was roughly about average. So even though we had average precipitation, if you bump up that temperature by 5 degrees, then basically all the ski areas do poorly. Like a lot of the ski areas closed in February, March. It was a really bad year. The glaciers had their worst year ever. And then one last glance, just at another recent kind of moderate strong El Nino. You can have poor snowpack during those as well. So yeah, now I'll hand it over to Kyle to talk about what we might see on the trails this year.
Yeah. So, to preface this, El Nino is not a guarantee of anything, but I'm going to talk about the recreational impacts we might see for a typical El Nino, let's say, where temperature is a little bit above average, a snowpack is maybe 80% of normal, and precipitation is around normal, a little bit under. So first I'm going to talk about skiing. And skiing definitely could suffer some from El Nino, but it tends to hurt the lower elevations more. So, getting a lift pass at Snoqualmie, backcountry touring at Snoqualmie is definitely could be more questionable this year, especially the kind of approaches that require a thicker low elevation snowpack. I'm looking at if Snoqualmie doesn't really get above a 50-inch base all season, that could make certain approaches where you leave any sort of trail or road at 2,500, 2,000 feet, could make those kind of approaches more difficult. So that might lean more to, areas where you can get to terrain that's 6,000, 7,000 feet, or you can take roads to a higher elevation that are okay with the thinner snowpack. So it doesn't mean that you won't ski some great powder this year, but it does likely mean that it will change a little bit the type of terrain that you can ski. It also will really change your access. So the last few winters, there's actually been quite a few low elevation snow events. And while that makes for great skiing in the places you can get to, sometimes it's kind of a bummer with regards to access. If we have, persistent warmer temperatures in a snow line of 2,500, 3,000 feet, we could see better midwinter access, some really awesome places like the Cascade River Road, the Mountain Loop Highway, other places like that for the last few winters have been kind of tough to access because of low elevation snow. So there could be a good opportunity to ski throughout a lot of the winter months in some really cool terrain. That's one positive aspect. Snowshoeing. So the main impacts on snowshoeing probably is a higher snow line, which would mean, certain trailheads are more accessible, different roads that aren't plowed, you might still be able to drive up in the winter. You might have to hike some before starting your snowshoe adventure for some of these trails, also like hike dry trail for 1,000 feet. And it could mean potentially more consolidated snow. If we have less total snowfall, you'll probably be in more periods of more consolidated snow, which makes for faster travel. Ice climbing, there's definitely considerations here. like the low elevations are probably not going to be as good during an El Nino year because of those persistent high temperatures. We still could get in a pattern where it's cold for a few weeks, or especially in Eastern Washington, and the ice could come in, but it's definitely a little bit less likely with those January and February months looking warmer than average. Now, the mid elevations and the higher elevations for alpine ice climbing, that's really a crapshoot and super hard to predict, probably the hardest thing to predict. 2018 and 2019 was a really good alpine ice year in the Cascades and in the Snoqualmie region. This photo is taken from them. So you never know if you get the right kind of pattern of freeze thaw, it could be good, but it's a very tricky one to predict. And then if you're looking to just kind of enjoy the lowlands and snow-free environments, El Nino could be a good winter. It's more likely that the Chuckanuts, the Issaquah Alps, and the foothills will stay more snow-free throughout the winter. So that's good for just trail running and mountain biking and activities like that. In the springtime, what we've seen from the data is a lower average snowpack on April 1st. So that likely indicates an earlier spring meltdown. Now, that also depends on how warm and how sunny our spring weather is. But all things being equal, it probably points to a little bit earlier of a spring season. That doesn't mean there won't be a great opportunity for spring skiing. In all likelihood, we will still have a deep enough snowpack to get some good corn cycles, and hopefully we can have a good spring season. But it likely will mean that spring and summer come a little bit earlier and you're moving into the high country earlier.
Cool. So a couple remarks to, finish. Like, one thing, as we've mentioned, like, El Nino is not gospel, right? It is not going to 100% determine what is going to happen. And you can have great snow years in El Nino, not like insanely good, but still pretty close to average, if not a little bit above. You can still get lowland snow, except it definitely happens less frequently. And you can still get out and really enjoy the backcountry. We'll include these in our description, some of these links, if you're interested in finding some of the data that we used. And also definitely want to give a shout out. If you want to watch another video, Michael Snyder, who runs Pacific Northwest Weather Watch, really, really great video, who goes into a lot more depth about how El Nino works and what might the impacts be on the West Coast.